So far, in this unit, we described about the electrical machines. Basic principle of the electrical machine was described in the previous classes. Then the construction was described. Then the armature winding was described in detail. We told the armature is having of two types, lap binding and web binding. How it was done? It was again simplex, duplex and triplex type of binding was there. Progressive in the clockwise direction and progressive in the anti-clockwise direction. The different type of armature binding was described in the previous classes. While describing the construction, we described there is a rotor. Main part of the machine is the DC machine is the rotor and the stator. Rotor is the rotatory part. This consists of the binding. Then it will call the armature, complete armature. Armature is suspended on the shaft. Apart from the shaft, there is a there is a commutator. Role of the commutator we described. It converts. It has the two roles. One, it converts AC into DC inside the armature. Voltage induced is the AC, and it is converted into DC with the help of the commutators. So there is a role of commutator. It collects the currents, convert to the DC and collect the current through the process. So this was described here. This portion. This is called the yoke, which is having. This is formed as I say, for example, this may be north pole, it is a south pole, north pole and south pole. Machine may have the 2-pole machine, 4-pole machine, 6-pole machine, 8-pole machine. Any type of DC machine as per the requirement can be there. So then winding, there are two types of winding. One is the field winding, another is the armature winding. Okay, field winding to this north pole and south pole, they can be of either electromagnetic or permanent magnet. Most of the time they are electromagnets. So how the electromagnet can be formed? By providing the DC current. Say for example, if this current is passing into this is the in the say anti-clockwise, if it is current is flowing into the, say for example, in this anti-clockwise, okay, then direction of current, this will be from north pole. In this, if it is anti-clockwise, here it will be clockwise, then it will be anti-clockwise, then it will be clockwise, like this. Two terminals are coming out. So in this way, this will be north pole, south pole, north pole, south pole. So binding of the stator, that is the field winding, is very simple. Okay. Now there is armature winding. Armature winding. Here we told the armature winding having, here there are slots. In the slot there is a number of turns. Here it may have 1, 2, 3 depending upon number of turns. Each coil may have the number of turns like this. Means like this and this. This type of coil is there. So this is the here. Here you can say this winding is here, and two terminals are coming out from this winding. Like this, there is a winding and two terminals are coming out. Now, in the armature, we know the voltage is induced. Our intention is we have to find out how much voltage will be produced in the armature, and we know voltage induced into the armature E will be the it is according to the rate of change of flux induced EMF is produced. For example, this armature with the help of this shaft, with the help of this prime mover, it is rotating with the speed of n. Small n is the rotation per second. If this rotor is being rotated with the speed of n is the rotation per second, then in each conductor, how many, what will be the flux? See here, the flux into this is 5, and if there are n number of poles, so total number of flux in one rotation, how much flux will be cutting by this conductor? Say one conductor is here. Here there is one conductor. In making this rotation from here to here, for example, there is one conductor. This conductor is in one rotation. When it is moving one complete cycle, how much flux will be produced? How much flux will be cutting this conductor? Flux in one pole is phi. Flux per pole is phi. Phi is the flux per pole. Phi is the flux per pole. And total number of poles? Total number of poles are P. Total number of poles are P. तो एक कंडक्टर पूरा राउंड लेने में कितना फ्लक्स कट करेगा? P into phi. Okay. तो total flux cutting is the P into phi. And how much time it will take in rotation? How much time it will take in rotating one complete cycle? If the speed is n rotation per second, कितना टाइम लेगा? If the speed is n rotation per second, तो एक रोटेशन में कितना टाइम लेगा? 1 by n. So the 1 by n. Okay, it means n p phi. This is the generated voltage per conductor. ठीक है? This is the generated voltage per conductor. Okay. It is a per conductor. But how many number of conductors are here? आपका, if you remember, now again come to the lap binding and web binding. The binding was, if you remember, this. In case of a web binding, this type of binding was there. Positive, negative. If it is a web binding, देखिए, voltage produced here, voltage produced here, voltage produced here, voltage. Total number of voltage कितना होगा? These conductors are in series. So total number of voltage produced क्या होगा? This is the voltage produced in one conductor. The total voltage will be produced the sum of all these conductors. Suppose the number of conductors are k, then k times. Okay. Now total number of total number of conductors can be there. Total number of conductors are say Z. Total number. Sorry, this is the term. The total number of conductors, symbol of this can be armature conductors. So total number of conductors are say for example Z. And if it is a web binding, so what will be conductor in one path? How many conductors will be there? Total conductors आपके बाइंडिंग में अगर Z है तो एक पाथ में कितने होंगे? Z by 2. अगर यहाँ 2 से डिवाइड है. अगर if it is a lap binding में क्या था? Lap binding में number of parallel paths are 2 parallel paths. In lap binding, number of parallel paths equal to A is equal to P. Number of parallel paths मतलब A is equal to P. तो इसका मतलब क्या होगा? Depending upon the parallel path, Z by A will be the conductor in one path. Okay, Z by A is the conductor per path. So what will be the total voltage in one path? Whatever the voltage here in one path, same voltage will be in another path. Lap binding, if it is lap binding, the whole number of the complete binding, total number of conductors are divided into the number of parallel paths, which is equal to A. In case of web binding, divided by 2. So it means total number of conductors are Z divided by number of parallel paths. This is the number of conductors in one path. Okay, Z by A. So total voltage produced from here to here. Total voltage produced from here to here. This E will be equal to this voltage. This is the voltage per conductor. Now total voltage will be equal to N P pi Z by A. Is this point clear or not? ठीक है? Sometime this can be written as this N. This N is written as capital N by 60. Where capital N is the rotation per minute. This is the RPM. In practical sense, it is given in the rotation per minute. जैसा आप machine you perform the laboratory classes. In the laboratory classes, you might have seen it is written on the machine RPM, rotation per minute. It is not written in rotation per second. So that's why most of the time in practical, in discussion, we call it as capital N RPM, so N can be written as a capital this N by 60 P I Z by A. This is the formula where capital N is the RPM. Okay. Now, sometime in terms of omega, what is omega? Angular speed of the rotor. And this angular speed of the rotor, omega is equal to 2 pi n. Is this clear or not? N is the rotation per second, omega will be 2 pi n. Okay? So, in place of n, you can write, omega by 2 pi. So, here you can also write omega by 2 pi, then it will be omega z p pi over 2 pi a. So this can be written as a k pi omega, where k is equal to z p by 2 pi a. It is 2. Okay. Now, so this is the formula 1, 2, 3, 4. Same. When we say how much voltage will be produced in the DC machine, how much voltage will be produced will be given by this formula. This is a very important formula. अगर आपको ये formula नहीं आ रहा, it means you cannot solve any question. This is the beginning. ये तो आपको याद ही होना चाहिए. If you are able to understand this derivation, then okay. Otherwise, this formula you should remember. E is equal to k phi omega, where k is equal to zp by 2 pi a. इतना voltage generate होता है. इतना voltage generate होगा इस पर. Okay? Any question up to this? Okay. Now what about this? About the armature winding, armature side, and with the help of Bruce's we can get this. Now this field winding. From there, this current will come. Just to make it as a phi, just to provide as an electromagnet, to provide this as a phi, the current has to flow into this. This current is called the field current. From where this field current will come. The armature, the representation of armature is like this. Representation of armature is like this. This is the representation of armature. मतलब what this shows? This shows rotor. Okay. This shows the reactance of the rotor. Yeah, resistance of the ideally if it is a देखिए normal way. In normal way, the reactance is not there in DC. It is in the AC component. But when we study the dynamics, dynamics during the fault occurs. When the fault occurs, there will be rate of change of everything. Rate of change of flux, rate of change of voltage. At that particular time, there is a AC, so there can be reactance. Otherwise, this is a resistance. Yeah, this is RA resistance. Okay. And what this represent? This is representing rotor. This is the resistance of the armature winding. These are the bruces. This is the representation. Now, this field winding is represented like this. This is a field winding. Now, depending upon the type of connection, from where this field will be given supplied. If there is a classification of DC machine, on the basis of the field, there is a classification of DC machine, and this can be, if it is separately excited, means if we give the positive and negative. If you give the separately excitation, बाहर से हमने कोई सोर्स दिया, उस सोर्स के थ्रू आपने इसमें डीसी सप्लाई दिया फील्ड करंट. Because of this field current, the flux will be produced, and like this, the current is flowing like this, the field flux will be in this direction. Flux. And rate of change of flux, this is the representation, equivalent circuit. So here the voltage will be produced. This is called the separately excited DC machine. मतलब हमारा जो DC machine है, we call it as a DC machine. We are not, although we describe this formula as a DC generator. The formula we have described for the voltage generated at the armature winding. So it is a generator. At the same time, it can be motor, it can be generator. So when we describe the motor, so that we will describe later. But here we call it as a DC because as I told, the structure will be the same. Either it is a motor or generator. So depending upon if it is a DC machine, can be separately excited, or another is the self-excited. Self-excited means क्या? Why to give the separate supply to this? एक तो यहाँ पे separate supply दिया, उससे field produce हुआ, field से आपका ये आ गया, voltage generate हो गया. And the question is, why to supply the field here? We can give the field from here itself. आपने इसको यहाँ connect किया, इसको यहाँ connect किया, तो it is a separately excited, मतलब self-excited. So self-excited can be not only this. Self-excited क्या हो सकता है? आपका suppose करिए, and this is just a field winding. Okay. When now the self-excited again can be of various type. If it is connected in parallel, it is called the self-excited. It will be called as a shunt-excited. Or if it is connected in series, then it is called the series excited. Which is called shunt-excited and series excited. ठीक है, इसमें कुछ पूछना है? तो
हेलो Just click on that. Hold on.
Any question?
Rashida,
Yes.
Question भाई कैसे है?
Huh?
सब कुछ आता है.
Yes.
Subscribe, like, comment, share.
Like, share बोलना है. Like, share and subscribe this channel.
Share.
Thank you.
Thank you.